In this video, we're going to continue looking at applications of exponential functions and consider questions involving compound interest. So here's the question. Herbert invests $5,000 in an account paying 3% annual interest. How much money is in that account after 10 years if the interest is compounded annually? Now, to answer that question, you have to understand what compounding means. Compounding essentially means paying you interest on your interest. If you invest $5,000 in an account and it pays 3% interest annually, compounded annually, that means at the end of 1 year, the bank looks at your $5,000 and pays you 3% of that. That goes into the account. Then, at the end of the second year, they look at the amount that's in your bank account at that point, which includes the original $5,000. That's called the principal. The principal is the initial amount. And it will also include the interest you got in the first year. Then they're going to pay you 3% interest on that whole amount. So you're earning interest on your interest. So that's what compounding means. So if it's compounded annually, that means that at the end of every year, they are going to look at how much money you have in the account and pay you your interest on that. Now, the interest rate per compounding period means we have to look at the amount of interest stated. It's always given as an annual amount, and we have to divide that by the number of compounding periods in a year. Well, in this case, it's easy because the amount, the account is paying interest compounded annually. That means that only once per year, so 3% divided by 1 would just be 3%. Written as a decimal, it's 0.03. So the interest rate per compounding period, in this case per year, is 0.03. And the number of compounding periods is also simple because after 10 years, if each compounding period is 1 year, there's been 10 compounding periods. Remember that the number of compounding periods is the same as the number of growth periods, so this is going to be our exponent. Therefore, we can solve the question by figuring that the amount that he's going to have at the end of 10 years is his initial amount, his principal, multiplied by, now it's not multiplied by 0.03, it's multiplied by 1.03, or 1 plus that 0.03 interest, because this 1 is him getting his principal back. If they just paid you 3% and hung on to your principal, you probably wouldn't keep your money in that account for very long. And the number of compounding periods is 10. So after 10 years in a bank account that compounds annually at a 3% annual compounding rate, if you plug this into your calculator, you get about $6,719.58 are left in that bank account. Initial amount, this is the growth rate per compounding period. That 1 is because you get your principal back, the 3 is from the 3% annual interest, and 10 is the number of compounding periods. Let's make it a little bit more complicated. He invests the same amount, $5,000, in an account, again paying 3% annual interest. Again, he's leaving it in there for 10 years, but now it's compounded quarterly. That means every 3 months, the bank is going to assess how much money is in there and pay interest on it. So the principal is the same. It's again $5,000. But now the interest rate per compounding period is different. If he's being paid 3% annual interest and there's 4 compounding periods in every year because it's being paid quarterly, then the interest rate per compounding period is 0.0075. Careful your number of zeros. And the number of compounding periods is 4 compounding periods per year times the 10 years, or 40. Using those pieces of information, we can work out that the amount after 10 years is $5,000 times, remember we need to put a 1 there to get back the original principal, 0.0075 to the power of 40. Put that into your calculator and you get about $6,741.74. So a bit more in this case because the compounding is happening more frequently. He's gathering more interest more quickly and then getting interest on that interest. So that's how to calculate compound interest. The key thing to remember is that the exponent is the number of compounding periods and that the base is 1 plus the annual interest rate divided by the number of compounding periods.